Good morning. Today I will teach you on how to solve certain problems on differential equation. But don't worry, it's not hard. Remember that all problems have solutions. Now we shall discuss about problem number 1. So we have here a given of x squared plus y squared quantity dx is equal to 2xy dy. So to know what form of differential equation, we shall observe it first. But as I can see here, I think that we can solve it using homogeneous differential equation rather. But homogeneous differential equation requires the equation to be homogeneous first. So to test if the equation is homogeneous, we have another variable here which is t. So we put it on the solution, and if t has the same degree between the right side and the left side of the equation, then it is homogeneous, so we now test it. So we have xt squared plus yt squared is equal to 2 times xt multiplied by yt. So as we factor this, we now have t squared times x squared plus y squared is equal to t squared times 2xy. So we can conclude that it is homogeneous since t between both sides, left and right, or right or left, have the same degree. So after proving that it is homogeneous, we can now continue solving the problem using homogeneous differential equation. So, because we concluded that the given equation was homogeneous, we can also conclude that y is equal to ux or u is equal to xy. Y is equal to ux or x is equal to uy. But I decided to use y is equal to ux. So we now have, if we differentiate this equation, we now have dy is equal to u dx plus x du using the product rule. So then we substitute the ux to the original equation. So we now have x squared plus ux quantity squared quantity dx is equal to 2x multiplied by ux and multiplied again by u dx plus x du, which is our dy. So factoring this equation above, we now have x squared times 1 plus u squared dx is equal to 2x squared u times multiplication multiplied by u dx plus x du. So we divide both sides by 2x squared u. We can now cancel x squared. So the remaining equation is 1 plus u squared over 2u dx is equal to u dx plus x du. Then we must transfer same, which has the same variables or form. So we now have 1 plus u squared over 2u dx minus u dx is equal to x du. Combining both, we now have 1 plus u squared minus 2u squared over 2u dx is equal to x du. Now, after that, we can now have 1 minus u squared over 2u dx is equal to x du. So we can now equate it. We have dx over x is equal to 2u du over 1 minus u squared. After that, we integrate both sides. So we now have integral of dx over x is equal to integral of 2u du over 1 plus u squared. So we now have there ln of x is equal to negative ln of 1 minus u squared. Maybe you're wondering why it is negative ln absolute value of 1 minus u squared. So I will explain it to you. So it's from here. We'll let this part be equal to x, for example. So 1 minus c squared equal to x. So the derivative of x, as we differentiate x, we also differentiate 1 minus c squared, which will be equal to negative 2u du. So negative 2u du here becomes negative dx over x. So we can now have negative ln of x. But x is just equal to 1 minus c squared. So we now have this. So we proceed. Ln of x is equal to negative ln of x squared minus y squared over x squared. Because our u here is just equal to when y is equal to u over x, so u is just equal to y over x. That's what happened here, and I just combine it. So that's why it has a common denominator. So combining with the rule of ln, so we now have ln of absolute value of x times x squared minus y squared over x squared is equal to 0. We can cancel x from the top and 1x from the bottom. So we have the remaining value of ln of x squared minus y squared minus ln of x, since ln of x squared minus y squared over x is just equal to this. So ln of x squared minus y squared transposing is equal to transposing the previous equation rather. Therefore, ln of x squared minus y squared is equal to ln of x plus c. So we're eliminating ln's. We now have x squared minus y squared is equal to cx. So transposing, so we now have y squared is equal to x squared minus cx, which is our final answer. See, it's easy. So we now go to our problem number 2. Our problem number 2 here, we have a given of xy prime prime is equal to y prime. So this equation is just equal to x du is equal to u, because if we'll let y prime be equal to u, so y prime prime is equal to du. So we have this. So combine, putting all u's on the other side and all x on the other side, we now have the integral of du over u is equal to the integral of dx over x, which is just equal to ln of u is equal to ln of x plus the constant c. So we have u is equal to e to the ln of x plus c, which can also be written as u is equal to e ln of x e to the c. So we now have u is equal to c e to the ln x, and it can be equal also to u is equal to xc ln of e, where ln of e is just equal to 1. So we now have u is equal to cx. But our u, since we'll let it kanina, which is y prime, our u is y prime, and our y prime is dy over dx, so we have it here. So dy over dx is equal to cx. So I'm putting again all same variables on the other side and all same variables on the other side. We now have dy is equal to cx dx, and integrating both sides, integral of dy is equal to integral of cx dx. After integrating, we get a result of y is equal to cx squared over 2 plus c. Factoring c out of the equation, we now have y is equal to c, quantity of x squared over 2 plus 1, which is our answer in problem number 2. So we'll now again solve for our last problem. Since I don't know the answer of the 2 other problems, I'm sorry about that anyway. I just told you that problems have all solutions. But unfortunately, my solutions of that 2 numbers I think are wrong, so I just didn't write it here. So we solve problem number 3. So we have a problem here of xy prime is equal to x cubed minus 2y, where y prime is just equal to dy over dx. So we now have a problem of x dy over dx is equal to x cubed minus 2y. Multiplying 1 over x to the overall equation, or to both sides, that's the same. So we now have dy over dx is equal to 2 over xy is equal to x squared, where our p of x is just equal to 2 over x. This is a linear differential equation, a form of linear differential equation. So we solve for our v. So we have v, the formula of v is just equal to e to the power of integral of p of x dx, wherein our p of x is just equal to 2 over x. So we now have here v is equal to e to the integral of 2 over x dx. So since 2 is just constant, we let it out first. So we have v is equal to e to the 2 integral of dx over x. So v is equal to e to the ln of x squared, since e squared ln of e to the 2 ln of x is just equal to e to the ln of x squared. So we now have v is equal to x squared. So multiplying the equation, the linear form equation with the v, we need to multiply the v rather to the linear form. So we now have here, so d derivative of the dependent variable times our v, which is y times x squared, is equal to the integral of this, multiplying this too. So we have x squared times x squared dx. So we have here d times y times d derivative of y x squared is equal to the integral of x to the 4th dx. So it is now equal to y x squared is equal to x to the 5th over 5 plus c. Multiplying 1 over x squared to both sides, or to the whole equation, we now have y is equal to x cubed over 5 plus c over x squared, which is our final answer. So thank you for listening to my video, and I hope you've learned something about it. So that's all. Thank you for watching.